On the back of your note sheet, let's do a couple more examples. It says solve the linear system and tell how many solutions the system has. If the system has one exact solution, find the solution. So I'm going to practice using the strategy that I think would be best for the problem that's given to me. And this one, since it says x equals this, I'm going to use substitution. I'm going to plug y plus 18 where the x is in the top equation. So negative 7 times x. I'm going to go back and fill in that. So x was y plus 18. So I'm going to substitute there. Now multiply negative 7y minus 7 times 18 is 126 plus 7y equals 7. And if you'll notice, when I go to combine my like terms, the negative 7y and the positive 7y cancels. And I'm left with negative 126 equals 7. And I know that's a false statement. Negative 126 does not equal 7. So this must be one where there is no solution. So not only does it not have one exact solution, it doesn't have a solution at all. And I know then that if I was asked on the graph, then that would make parallel lines. The next one looks like it's lined up pretty good. The x's are in line, the y's are in line, equal sign in line, and the constant term are in line. So I'm going to use elimination on this one. So to get the y numbers to be the same, it looks the easiest to me, I'm going to multiply the bottom equation times 2. So the top equation stays negative 6x plus 2y equals negative 2. The bottom equation, when I multiply 2 times every term on both sides of the equal sign, I get negative 8x minus 2y equals 16. So since I have positive 2y and negative 2y, I know that I'm ready to add. So this would be negative 14x plus 0, those eliminate, equals 14. So when you divide both sides by negative 14, you get x equals negative 1. So this means this one is going to have one exact solution. So let's go back and find what the y part of my solution will be. I know the x is going to be negative 1. I just need to find the y. I think I'll pick the top equation again. So negative 6 times x, and x was negative 1, plus 2y equals negative 2. So 6 plus 2y equals negative 2. Subtract 6 from both sides. So 2y equals negative 8. Divide both sides by 2, so y equals negative 4. This one has one exact solution. That solution is negative 1, negative 4. That means if these lines were graphed, they would cross at one point, negative 1, negative 4. Okay, let's keep going down here on the bottom part. This next one looks like it would be great. The x's are lined up, the y's are lined up, the numbers are lined up. All of the variables have a number in front of them that is not 1. So this one's an ideal equation to solve by elimination. Since this has negative 6, I want to try to get positive 6 right here. So I'm going to take the top equation times 2. So an equivalent equation to the top equation would be 6x minus 4y equals 6. The bottom equation is negative 6x plus 4y equals negative 6. And some of you are probably already noticing that 6x and negative 6x are going to eliminate. Negative or positive 4y are going to eliminate. So the left side is 0, and the right side eliminates also. And this is a true statement. So this one is going to have infinite many solutions. So this means if I graphed this one, the line might look something like this. If I graphed that one, it's going to look something like this. They're going to be a line on top of itself, so we would call that two lines that coincide. They were equivalent from the very beginning. Alright, this next one looks a little bit messy to me, so I think that I'm going to try to just get rid of the fractions on these. So I'm going to take this top equation times the least common multiple. I'm going to multiply it times 4 to get rid of the denominator. So when I multiply this times this, the 4 cancels, so I get 3x. When I multiply times here, 4 times a half is 2y. And then 4 times 10 is 40. That one looks way better. To get rid of the denominator on the bottom equation, I'm going to multiply everything times 2. So 2 times negative 3 halves is negative 3x. Hey, I like that. When I multiply 2 times this, I get minus 2y. And 2 times 4 is 8. So what I see here is I have 3x and negative 3x. That eliminates. And 2 and negative 2y. That eliminates. So I get 0 equals 48, which is no solution. So this means those lines would not cross at all.